A notable earthquake swarm has been unfolding in Idaho, persisting for over a week and steadily gaining intensity. The strongest recorded event thus far is a magnitude 4.0 earthquake, accompanied by multiple tremors in the 3.9 range. This pattern has sparked considerable scientific and public interest, raising the question, is the region's fault system currently relieving tectonic stress, or could this be a foreshock sequence preceding a much larger seismic event? Idaho ranks as the fifth most seismically active state in the US, with a well-documented history of powerful earthquakes spanning the last 150 years. The area's geologic volatility is underscored not only by its frequent tremors, but also by its proximity, approximately 230 miles to Yellowstone, another hotspot of geological activity. Recent seismic data from the US Geological Survey, USGS, reveal that the swarm began around May 20th and has grown more intense over time. Earthquakes have increased in both number and strength, culminating in several moderate tremors on June 3rd alone, including magnitudes of 4.0, 3.9, 3.8 and 2 at 3.6. The average depth of these quakes is about 7 kilometers, suggesting a relatively shallow origin within the Earth's crust. Despite the growing frequency and intensity of these events, the total energy released remains modest. The cumulative seismic moment of the swarm equates to roughly a magnitude 4.4 earthquake. For context, a single magnitude 5.0 earthquake would release approximately 32 times more energy than this entire swarm combined. From a scientific standpoint, these swarms are particularly valuable. Unlike singular large quakes, a series of smaller tremors offers richer and more granular data, allowing researchers to better interpret subsurface fault structures and the geodynamic behavior of the region. While the swarm may appear alarming, it serves as an important window into the ongoing tectonic processes shaping Idaho's complex geological landscape. While a cumulative magnitude of 4, the 4th of May, not seem remarkable in isolation, its significance increases when considered within the context of a growing earthquake swarm. The recent uptick in seismic activity in this region of Idaho warrants attention, particularly given the area's history of powerful earthquakes. Seismic records dating back to January 1, 1955 show that Idaho has experienced several major events, including a magnitude 7.2 earthquake in 1959, a magnitude 6.9 in 1983, and more recently, a magnitude 6.5 quake in 2020 near Stanley, strikingly close to the current swarm's epicenter. Though the calculated cumulative magnitude of this swarm only reaches about 4.4, which implies limited energy release, the concern lies in its potential implications. Rather than simply venting minor tectonic stress, this swarm could be the precursor to a more significant rupture. While there's no certainty that a larger earthquake will occur, the possibility cannot be dismissed, especially in light of the region's seismic legacy. Hazard maps of the United States clearly identify this part of Idaho as a high-risk seismic zone. While California remains the most seismically active state with dense infrastructure atop complex fault systems, Idaho's fault zones are also capable of producing powerful quakes. The hazard here is shaped by a combination of geological factors, including fault stress accumulation, local soil composition, and structural vulnerability. Compared to denser population centers in other seismic zones, the current swarm in Idaho is occurring in a sparsely populated area. This geographical factor may reduce the potential human impact if a major quake does strike. Still, residents in the region are advised to take the threat seriously. Having a well-thought-out earthquake preparedness plan can make a critical difference. This includes knowing safe locations during shaking, storing at least 72 hours worth of emergency supplies, such as food, water, and medical essentials, and ensuring access to alternative power sources. Earthquakes in the magnitude 6.5 to 7.0 range can inflict widespread damage, and readiness remains the most effective defense. The broader geological framework surrounding Idaho helps explain the region's frequent and sometimes powerful seismic activity. This area is shaped by complex tectonic interactions and diverse geological features that have developed over millions of years. Not far to the east lies Yellowstone, a volcanic hotspot fueled by a deep mantle plume, adding thermal and magmatic energy to the region's already dynamic geology. A crustal magnetic anomaly map which filters out Earth's global magnetic field to highlight variations in the crust itself, reveals dramatic shifts in magnetic intensity across the western United States. Warmer tones, such as reds and pinks, indicate positive magnetic anomalies, while cooler shades, like deep blues, signify negative anomalies, measured in nanoteslas. These variations reveal deeper structures and processes within the Earth's crust. On the west coast, strong magnetic anomalies dominate regions like Washington, Oregon, and California, corresponding to younger, accreted geological terrains. However, near the Idaho border, these anomalies sharply weaken. This boundary reflects a major geological transition known as the Western Idaho Shear Zone, a long-standing tectonic feature that separates the relatively younger accreted crust of the West from the older, more stable North American craton to the east. This juxtaposition of contrasting crustal blocks contributes to the region's seismic complexity. Overlaying this tectonic mosaic are enormous batholiths, massive bodies of crystallized magma deep within the crust, primarily composed of hard, dense rocks like granite and diorite. These batholiths, remnants of ancient volcanic activity, are embedded within Idaho's crust and influence stress distribution during tectonic movements. Since the 1950s, Idaho has experienced several significant earthquakes, including events of magnitude 7.2, 6.9, and 6.5. These quakes tend to cluster near or along major structural boundaries, particularly around the western Idaho Shear Zone and just to the east. Within the mountainous terrain shaped by the Sevier thrust belt, this region continues to experience slow but persistent tectonic compression, contributing to ongoing seismicity. Idaho's seismic profile is further intensified by its unique position between powerful geological forces, the dynamic tectonics of the Pacific margin to the west and the volcanically active Yellowstone region to the east. This convergence of tectonic shear, ancient batholiths, and thermal anomalies makes Idaho one of the most seismically active states in the US, ranking 5th in historical earthquake activity. Taking a broader perspective, the global pattern of seismic activity in 2025 up to June 3rd reveals some compelling trends. The year began with a relatively calm seismic profile characterized by low to moderate earthquake frequencies. Though a few notable quakes occurred, such as a magnitude 7.6 near the Cayman Islands, overall, the early months were quiet in terms of major seismic disruptions. That changed significantly around mid-March, marking a pronounced escalation in global earthquake activity. March 28th in particular stood out as an intense day of seismic unrest. On that date, Myanmar experienced a powerful magnitude 7.7 earthquake, accompanied by strong aftershocks measuring 6.7 and 6.6, as well as additional quakes of magnitude 6.0 and 6.1 along a mid-ocean ridge. Not long after, a magnitude 7.0 earthquake followed, and more recently, a magnitude 7.4 struck off the southern coast of South America. This noticeable increase in seismic activity aligns closely with concurrent changes in solar behavior. Around the same time, large coronal holes began appearing on the Sun, phenomena that have been repeatedly linked in scientific observations with elevated global seismicity, particularly in the case of high-magnitude events. These solar disturbances, by influencing Earth's magnetic environment, may play a role in the timing or triggering of tectonic movements. The broader seismic landscape continues to show elevated potential for strong earthquakes. As such, regions with existing tectonic vulnerabilities, such as the state of Idaho, cannot be excluded from the ongoing risk. The prevailing planetary dynamics suggest that the Earth is currently within a phase where larger earthquakes are more probable. One notable example of regional seismic precursors unfolded in the Aegean Sea near the volcanic island of Santorini. In early February, a concentrated swarm of earthquakes, some exceeding magnitude 5, was detected in the area. This swarm was followed by a series of significant tremors spread across the region. 2 magnitude 6 plus earthquakes near Crete, a magnitude 5.8 off Turkey's southwestern coast in the last 24 hours, and a magnitude 6.2 near Istanbul on April 23, accompanied by aftershocks. Additional seismic events have been reported throughout Greece, indicating a spatially distributed pattern of tectonic activity. This sequence suggests that the initial swarm may have served as a harbinger of broader regional stress release, unsurprising given that the Aegean is among the most seismically active zones on the planet. This Emerging seismic rhythm both globally and regionally underscores the interconnectedness of geophysical processes, from tectonics to space weather, and the importance of remaining alert during such dynamically charged periods. But a notable seismic swarm is currently unfolding in Idaho, raising the possibility of increased earthquake activity in the region in the coming months. While nothing is certain, the pattern suggests that the area may be entering a more active seismic phase. Globally, seismic activity has been elevated recently, though there are signs it may now be declining. Still, it is important to recognize that Earth has not experienced a magnitude 8.0 or greater earthquake since August 2021, an unusual gap, as such large events typically occur at least once per year. The most significant quake since then was the devastating sequence in Turkey on February 6, 2023, which included magnitude 7.8, 8.0 and 7.5 tremors. The recent 7.7 magnitude event came close, but no true magnitude 8+ earthquake has yet materialized. In Idaho, historical records suggest that quakes of that magnitude are unlikely, with the largest events in the modern record reaching 7.2 in 1959, 6.9 in 1983, and 6.5 in 2020. However, seismic behavior is inherently unpredictable. While past data can offer guidance, it cannot rule out the unexpected. For that reason, scientists are monitoring the region with particular attention, aware that even low-probability scenarios deserve vigilance. Thanks for watching. If you found this update insightful, don't forget to like, share and subscribe to stay informed on the latest seismic activity and more. Your support helps keep this channel going, so hit that bell icon and join the community for regular updates. See you next time.